Hello, so let's start the Fibonacci number. We are basically gonna cover in linear DP three questions, so your concept can be like clarified, like no doubt remains. So let's start with like what do you know about Fibonacci number? Like Fibonacci number is basically like 0, 1, 1, 2. Like it is the current number is the sum of previous two numbers like 3, 4, sorry 5. So like this we have like Fibonacci sequence. So initially we can like generate it using recursion, but we need to improve this recursion version since it basically takes factorial time. So second, on improving recursion we have like memoization as well as tabulation. Like we are gonna see the memoization and tabulation code, but before that we need to solve it using recursion. So like basically we can have a base case like if n less than equal to 1, like if we have only one number, then it will not be possible to generate the sequence. Like it will be if like suppose for 0 we can have any Fibonacci sequence since this it is the only one number, and for generating a sequence like Fibonacci sequence we need the sum of previous two, but in case of 1 also there is only one number, so like we have to return the n only, and at last we should return Fibonacci of n minus 1 plus fib of n minus 2. You can know this is the basic recurrence for Fibonacci we should use since it is the sum of last two. So it is running, but here we can see the complexity will go like 2 to the power n exponential complexity. So we can't like use this approach. So basically we need to reduce the complexity. So for that we basically use memoization. And what is memoization? Like let me show you. Suppose we have to calculate f of 3. For f of 3 we need to calculate f of 2 plus f of 1, and for f of 2 we need to calculate f of 1 plus f of 0. But you can see here when we are calculating the value of f of 3, then we have already calculated f of 1, but so we should store it in somewhere, like in f of 2 we also have to calculate f of 1, so it will be like wastage of like computation since we have already computed, so we can use the value here. So for that we basically use memoization. It is basically like you have to like remember the previous calculator value so you can use it further. This was the concept behind the memoization, and it is basically a top down approach. Like we have been given n, like n equal to 5, and we need to reach the base case like n equal to 1, or we can say 0 in some cases. Like there is one case we will show you like in climb stairs problem. So let's focus now for this. So this was the base case, we need to like comment down. So first of all we are gonna implement the memoization fib helper, and first of all we need to declare out dp. So since it here only one state is changing like n, so we are using 1d array, 1d dp array, vector int dp and plus 1 comma minus 1, and plus 1 is basically we are taking for safety, like so for fib helper we need to pass the n as well as the dp array. So for fib helper implementation, int fib of helper int n and vector int address dp. You can basically declare dp globally, but in interviews it is not preferable. So here we are gonna do the same thing, less than 1 return n, and like at last return fib helper n minus 1. But here we have to remember that we also have a second parameter as dp, fib of helper and minus 2 dp. So we basically have to store this result somewhere, so we don't have to recompute if it is required for computation of another term as well, like dp of n equal, like we have stored it. And we also have to put a check, like if we have already calculated, then we don't recalculate or recompute it. Like if dp of n not equal to -1, then we should have to return dp. Since we can think like, since it is already all the values of a dp has been filled with -1, and if we haven't encountered -1 means yeah, we have already filled it. So like I hope this should run. Yeah, this is also running. Here what is the complexity, like for memoization, yeah, for memoization we are basically taking space complexity of big of n for the helper for the dp array, and time complexity of big of n. So big of n for both space as well as time complexity. But if we consider recursive stack space, then space complexity will be like big of n, big of n, this is the dp array space plus big of an array space, this is recursive stack space, and time complexity will be big of n. So this was the memoization approach, and we basically want to remove the recursive stack space. So for that we basically do further tabulation approach. It is like bottom up, like we need to have a base case and from there we need to reach n. So let's proceed with the tabulation approach. And basically you want, if you want, then you can use helper as well for tabulation, but basically we do like in the main function, um, as well. We basically do in the main function the tabulation implementation, like it will be same dp of n plus 1. So after dp of 1, here we have like seen for n less than 1 we have to return n. So what we can think of in base case, like dp of 0 can be 0 since the initial states I am declaring, and dp of 1 it can be 1. So now we have found the state still 0 1. So what we can do, like we can traverse through the whole, we can traverse still and from starting from 2, since 0 and 1 are already covered. So for int I equal to 2, I less than n, I plus plus. And what I have told you, that we don't have to use recursive stack space, so we don't gonna use this type of function. So basically we are like calculating dp of I equal to dp of I minus 1. We are directly doing the calculation in the dp array itself, dp of I minus 2. And at last, oh, suppose, let me show you one thing. dp of, since dp is a like minus 1 minus 1 minus 1, yeah. So I basically want to say you, like when we are doing the computation, our answer will be always stored at the last place. So like, let me comment out, since we are computing like this plus this, like for are used for this calculation, so basically answer will be at present at the last. So basically we will do return of dp return of dp of n. Let me check if it runs. Hmm. Like dp of I, sorry, we have to, like I have to do for Yeah, so here the complexity will be like big of n, and for space complexity big of n for vector dp will be required, and big of and recursive stack space will not be required for this. So thank you.